Now we go to synchronous machines. So synchronous means the speed is matching. That is the meaning of the word synchronous means some two things are having the same property. So in a synchronous machine, the rotor speed is exactly fixed by a supply frequency. So the three-phase synchronous machine can be used as a synchronous generator or a motor. So you know that synchronous speed we have learned. Synchronous speed is the speed of the rotating magnetic field. So same way here, synchronous motor means the speed is fixed by the supply. The supply is going to fix the speed of the motor. So the device can be either a generator or a motor. So we can use it anyways. And a synchronous generator, it is going to generate electric power, and it is generators are also called by another name called as alternators. So whenever you are going to use to see the term alternator coming into picture, it is going to be the uh, generator, synchronous generator. So see here, you are going to give a DC electrical power, and you are going to give a three-phase electrical power, and it is going to cause mechanical rotation. So if the flow is this side means it is generator. If the flow is this side means it is going to be motor. Okay, so that is given in the diagram. So the from right to left, it's going to be motor. I'm going to give supply. The shaft is going to rotate. If I'm going to rotate the shaft, I'm going to get electrical power. So that is going to be the generator is going to be from left to right. Motor is going to be from right to left. So external connections is shown here. It has two connections. One is your DC field, and another one is your three-phase connection. So the mechanical system is under the rotating shaft. You know that whatever load you have, you can connect it here. This is going to be your rotating shaft. It is going to rotate. So the DC field is placed on the rotor, especially rotating electromagnet whose flux is controlled by the exciting DC current. So this DC field is going to be given to the rotor. So this DC field is going to produce magnetic flux, which is going to be controlled by the current coming out of this DC source, DC electrical power. So the DC power supplied to the field circuit supplies the ohmic loss, but does not directly enter into energy conversion. The DC power supplied to the windings will not be calculated for the energy conversion process. So the armature is placed on the stator and carries three-phase current. So you know that the flow of real power is determined by the mechanical input because the mechanical power exchange is real power only. In mechanical system, we don't have what is called as real power, reactive power, and apparent power. Only in electrical systems, we have three types of power because we have three types of components: resistor, inductor, and capacitor. Correct. But in a mechanical system, only real power only is meaningful. We don't have the concept of reactive power and apparent power. For generator action, mechanical power minus the losses becomes the three-phase output power. For motor, real power from the electrical minus the losses becomes the output mechanical power. So please be clear on the power relation. Always you have to subtract the loss to get the other power. In generator, to get the input power, input minus loss will be equal to output. In motor also, input minus loss equal to output. In generator, input is mechanical, output is electrical. So the equation will be accordingly written like that. For a motor, the input is electrical and output is mechanical. The equation will be written accordingly. In that case, see, this is what is given in point number 4. Please spend time and read it correctly. So when you are going to place load on the generator, the reactive power flow is controlled by the DC field current. When the machine is operated as a motor, the reactive power required and just the power is controlled by the field current. In both the cases, we are going to have field current, and we are going to say that this field current is going to take care of the reactive power. Okay, the output power is determined by the three-phase supply. Okay, but the field current is going to be quantified as the reactive power. So the direct control of reactive power is surprising and extremely useful property of synchronous machine. So this reactive power also you can control it in synchronous machines. So this is going to make the synchronous machines even more advantageous. Okay. Any doubts so far? See, so we are just learning the basics of motor and generator here because this is going to be synchronous machines. The meaning of synchronous machine is the rotation of the rotor is going to be fixed by the DC supply.